Ooh, finally some programs on this. So this is the saver with a Frankenstein component, and then the add-on board on top. So the progress now is software. So I'm supposed to program here, but I'm just doing it on an 80 tiny here. So to get the display going, and finally I get hello world. And you have no idea how long I've taken for me to get that make file going. So as you may know, I'm currently programming every day, and I am spending a lot of time in C, programming in C and make files and everything. So these examples are not always working. So the example I'm following is Adafruit SSD 1306. I just use it for reference, but the real one I'm using here is Tinyusaur project, because this one is supporting 80 tiny. So, and it didn't work. So first of all, it was the make file. Yes, this library doesn't work so well. So because it's 128 by 64, and this one is 128 by 32. So I was thinking, okay, what do I need to change to make it work? So I looked at Adafruit, and she has some interesting stuff in the initialization part. So here you can see the begin part, and here's an init sequence. So yeah. So I just went in there and saw like, okay, LCD height, that's interesting, right? And funnily, there are written hex values here. So if you go to my file, what I've done, basically I put it side to side here, and I find A8 and then A8, and I just change it from half of that, which is the ratio, and something else down here, which was saying if it was 128/32, then you have to do this and this, and so I did, and it works. So that was really cool. Just wanted to say that. I don't think I'm going to go into that, but make files is like a set of rules, and you put all your objects in there. There you go. So when I write make, it will make all the objects. The whole objects is just a machine code, sort of. So, but it's made for every C file. So I have to, first of all, I had to get this right. All of these paths, you can see object. So there's a C file that gets an object. Then the string is used by this one, and this one is used by this one. This is important, actually. So this is what the make file sort of, it knows what needs to be made first. So yeah, so that's the file I'm burning. So what is holding me back, and what haven't I told you? Well, I built this board, and this is the add-on board. So the idea here is that if I take this old lady thing, I can insert it here. Then I don't have the box, but all of this is supposed to fit in a box. And then you have a button on the side, so you can control. So you're supposed to see voltage, current, and a menu. So the menu, you're supposed to also be able to configure it to cut off at a certain current. For example, you say you wanted to cut at 1.5 amperes, you can set that, because we have instrumentation here. So what do we have on the add-on board? We have the 80 tiny, which was a bit 2mm too big for the footprint, so I've just crushed the legs in to get it to fit. It's a long story. Then we have the ACS 712, which is a Hall effect, and turn it into a voltage. We have ENA 219, that's an I2C enabled device, so basically it can sample current and voltage, and it can also average that and send it back to the microcontroller. So, and this one is the second one. You can see this is also has SCL and SDA. And what is this then? Well, that's these three guys here, this one, and this one, they are isolation devices. So this one isolates the I2C bus, and these are basically giving me control. So I can say, the microcontroller can say switch the output here via this one. So it basically controls one of these pins, and then this output is clamping together in an isolated manner. So the reason for that is because the board runs off of 9 volt AC, which is isolated from the 5 volt, and if I want to control the 5 volt section, I need to isolate. So, and also this one is reverse, you can see the notches here, and that is an indicator from the 5 volt part from the, yeah, there you can see the Frankenstein circuit. So when this guy, or this guy, I don't remember, okay, that's the one, D1, that's a TL431, it sets the trip point at 5.4 something, and then the output of that is then fed. Oh, that makes this one switch and the transistor, and it's picked up here. So when that happens, the output here changes, even though it's isolated. So it's basically controlling an LED inside here, and then this one changes. And the microcontroller on the 9 volt side can pick that up though. So you can actually see on screen that, oh, now we have a fault, right? You need to indicate that somehow. So this one can be run without all of these things around here and this board. You don't need this board to run this thing. It's just when you want an add-on board you need it. So yeah. So I was thinking, there's not that many are going to use this add-on board, but I'm thinking when people are repairing a lot of the Commodore 64s and VIC-20s, and sometimes I've seen at the saver they say that, or like for example, Mindfray Retro told me once that the light went out on the saver, the green light. So, and that was a fault on the board, on the Commodore board, which dragged the power down. So that didn't trip the fuse for some reason. The saver got very warm or hot, but with this one you would have either you could just see it, or you could configure it to shut it off or trip, so it cuts the 5 volts. So yeah, so that would be really cool. So I think that's all the use cases. Maybe you have some ideas for more use cases for this. So as I said, I'm not planning to make many of these. I was thinking to make them for people I know and who repair Commodores, so they have a tool for diagnosing problems like power, because power is always the first thing you should check anyway. So, and checking the amount of power is not always so apparent unless you have a lab power supply, or a power supply with a meter on it. So yeah, also the second thing I want you to be able to configure here is you can, if there is a fault, you can select if it wants to auto reset or not. It keeps the output low even though the voltage come down again. The reason for that is sometimes you get power supplies with dry capacitors, then there will be like a 50 Hz thing and it will switch on and off very fast. It's not dangerous, but well, you can detect that. Maybe I can make a algorithm that says something about that on the screen. The idea that I'm not using the microcontroller for everything is that the baseboard is doing the main function of saving the Commodore 64. So even though microcontroller breaks down or doesn't run anymore, something happens to the oscillator or anything, so you still have protection. So because this device, this TL431, will still operate. It's much simpler. Everything here is much simpler. In here, in the microcontroller, you have millions of transistors, maybe 100,000 or something, maybe not millions. I don't know. But there's more that can go wrong, right? You can have hiccups. You can have the program can reset, and yeah, you know, it's not good. So yeah, so if you like that, so a little bit information. I haven't tested it. I need some programming tools. I have now started to work out the the problems with software. You know, it's so hard. Even though I do this every day now with C, and I find libraries online, and now they're mixing C and C++ and Arduino. And the main reason I'm not using Arduino, even though it's very easy, is because if you have make files, I'm pretty sure it's much easier to get someone else to continue on the project by just having your files. You basically have a copy of your directory. So, like here, like sources. You see, I have main C. Now it's a lot of files there. So if I do make clean though, just get away all of those make garbage. So there you go. Yeah. So if you have these files, and then I have included the library, Tinosaurus library, you can just write make, and then it will work. But in Arduino, you have to get the correct library, and sometimes I think some libraries don't go so well together. So you have even though you have extremely user friendliness in Arduino, there's also a bit difficult to sort of get it so user friendly, because you have to, like, okay, you have the INO file for the Arduino sketch, but then you need to tell them to get the libraries also. Maybe that will be easier in the future by project. Maybe that's something it's coming. I don't know. For Arduino, that would be great if you could have requirements. You could go into projects, the project preferences or project properties, and then say, okay, this project needs this library and this version, and blah blah blah, and then yeah, it gets that automatically when you press compile. So. And yes, hope you liked it. See you another time. I probably forgot to tell you something. We'll be back soon. I just wanted to give you a little video. I'm also working on the electronic load. You can see up here. RAM card. This is a nunchuck. I have sent 10 nunchucks out to people.